Space is completely dark. Space is not actually filled with the vibrant, glowing nebulae often seen in edited photographs. To the human eye, most of the universe is a void of absolute darkness. Because space is a vacuum, there are no particles like dust or gas in high enough concentrations to scatter light as our atmosphere does on Earth. When an astronaut looks away from a direct light source like the sun or a planet, they see a blackness so profound it can cause a loss of depth perception. This happens because light only becomes visible when it reflects off an object or enters the eye directly from a source. In the vast gaps between celestial bodies, there is simply nothing for light to hit, creating a visual experience of infinite shadow. Even when surrounded by billions of stars, the sheer scale of the emptiness ensures that the background of the universe remains darker than the deepest night on our home planet. Space is silent. Sound waves are essentially vibrations that require a medium, such as air or water, to travel from one point to another. Because outer space is a near-perfect vacuum, there are no molecules to carry these vibrations, making the cosmos a realm of total and haunting silence. Even a massive supernova explosion, which releases more energy than the sun will in its entire lifetime, would occur in complete acoustic stillness to an outside observer. Astronauts can only communicate through radio waves, which are a form of light and do not require a medium, or by touching their helmets together to allow sound to vibrate through the solid material. This silence is often described by space travelers as one of the most isolating aspects of extravehicular activity. While movies often depict roaring engines and whistling lasers, the reality of physics dictates that the most violent events in the universe happen without a single whisper or bang. Stars don't twinkle. The familiar twinkling of stars in the night sky is entirely a trick played by the Earth's atmosphere rather than a property of the stars themselves. As starlight enters our atmosphere, it passes through layers of air with varying temperatures and densities, which causes the light to refract or bend in different directions. This turbulence makes the star's position and brightness appear to shift rapidly to someone standing on the ground. In the actual environment of space, stars appear as steady, unwavering points of light that never flicker or dance. They also look significantly sharper and more intense because there is no moisture or pollution to blur their appearance. From the perspective of an orbiting satellite, stars do not just sit still. They appear in colors that are much more vivid, ranging from deep reds to brilliant blues depending on their surface temperature. The sun looks white. If you were to view the sun from the cockpit of a spacecraft, it would not appear yellow or orange, but a blinding, pure white. The yellow hue we perceive from the ground is caused by the Earth's atmosphere scattering shorter wavelengths of light, such as blue and violet, more effectively than longer wavelengths. This scattering leaves behind a dominant mix of yellows and reds, which gives the sun its characteristic golden glow at noon and its deep red color at sunset. In the vacuum of space, however, all the colors of the visible spectrum reach the eye simultaneously and with equal intensity. Since the combination of all visible light frequencies results in white, the sun reveals its true color as a white star. This white light is incredibly intense, requiring specialized gold-coated visors on spacesuits to protect the eyes of astronauts from permanent damage caused by unfiltered solar radiation. Earth isn't fully blue. While Earth is famously known as the blue marble, its actual appearance from orbit is a complex mosaic that includes significant portions of brown, green, and brilliant white. From a distance, the vast oceans do provide a dominant blue backdrop, but the presence of massive weather systems often obscures the surface with swirls of bright white clouds. The continents appear as rugged patches of tan and brown in desert regions, while dense forests show up as deep, dark greens that can almost look black from high altitudes. During the winter months, large sections of the northern and southern hemispheres turn a stark white as snow and ice cover the landmasses in polar regions. Additionally, the thin layer of the atmosphere creates a glowing blue limb around the edge of the planet, which is the only part that appears consistently blue regardless of the terrain below. Galaxies are far apart. The scale of the universe is so immense that the distance between galaxies is almost impossible to comprehend using terrestrial measurements. Most popular depictions of space show galaxies crowded together like islands in a lake, but in reality, they are separated by millions of light-years of void. To put this in perspective, if the Milky Way were the size of a small dinner plate, the nearest major galaxy, Andromeda, would be located about 25 feet away. The space between these galaxies, known as the intergalactic medium, is so empty that it contains, on average, only one atom per cubic meter. This vast separation means that even though galaxies are moving toward or away from each other at incredible speeds, collisions take billions of years to occur. The light we see from distant galaxies today has often traveled across these empty stretches for longer than humans have existed as a species. Space isn't empty. Although space is frequently called a vacuum, it is not truly empty, but is instead filled with a thin soup of particles, fields and radiation. This interstellar medium consists of hydrogen and helium atoms, cosmic rays, and microscopic dust grains that act as the building blocks for future stars. Space is also permeated by the cosmic microwave background radiation, which is a faint glow of heat left over from the initial expansion of the universe. Additionally, magnetic fields stretch across the cosmos, guiding the movement of charged particles and shaping the structures of entire galaxies. There is also the mysterious presence of dark matter, which does not emit light but exerts a gravitational pull that holds galaxies together. Even in the deepest voids, gravity is always present, ensuring that every point in space is connected to the rest of the universe through invisible physical forces. Space is cold. While we often think of space as cold, the concept of temperature works differently in a vacuum because there is no air to hold or conduct heat. If you were standing in direct sunlight in space, the side of your body facing the sun would heat up to over 100 degrees Celsius, while the side in the shade would drop to nearly minus 150 degrees. However, the average temperature of the background universe is approximately 2.7 Kelvin, which is just slightly above absolute zero. This is the temperature at which all molecular motion nearly stops, and it represents the residual heat from the Big Bang. Because there are so few atoms to transfer energy, an object in space loses heat very slowly through radiation, rather than through contact with the surroundings. This means that while space is technically freezing, the primary danger to a traveler is often managing the extreme heat from the sun, rather than the cold of the void.